today's lesson to you. So we are going to do it via video. If you remember last class, we learned an introduction to probability. So we found the probability of a single event. Okay, so for example, we found the probability of randomly drawing a king out of a deck of cards. So if you remember, we had 4 kings, and there's 52 cards in a deck. So all we did was 4 divided by 52, and that gave us the probability of drawing a king out of a deck of cards if I choose a random card. So today we're learning about the probability of compound events. Okay, so for example, a compound event will be what's the probability that I draw either a king or a jack from a deck of cards. So we would take the probability of drawing a king and the probability of drawing a jack, and we would add those probabilities together. So when we are dealing with these compound events, we need to consider 2 different things. So it says at the top, when you consider all the outcomes for either of 2 events, which we call A and B, you form the union of A and B. So here's a Venn diagram that shows us what the union of A and B looks like. Okay, so I have, let's say A were my kings and B were my jacks. The union of A and B would be all of the kings and jacks. Okay, then we have something called an intersection of A and B. So an intersection is when my 2 events have something in common or they overlap. So here's my Venn diagram. Here's A and here's B. This shaded region would be the parts that are in both A and B. So an example of that would be if I was drawing a card and I want to know what was the probability that I draw a red card or a king, because I have 2 kings that are also red cards. So there's 2 cards that are both a king and red. Okay, so that would be an intersection. It fits both of the events. Okay, sometimes I don't have an intersection. Like if I go back to my example about kings and jacks, there are no kings that are also jacks. So the intersection of those 2 events would be empty. Okay, now in this box right here, it's talking about the probability of compound events. So I have 2 formulas to help me figure out the probability of 2 events. So if A and B are 2 events and they don't have anything in common, to find the probability of A or B, I take the probability of A plus the probability of B. I'm sorry, this is the one that does have something in common. And we subtract the probability of A and B. So if I go back to my cards example, if I want to know what are the odds of drawing a red or a king card, I would take the probability of drawing a red card, which would be 26 out of 52. And I would add the probability of drawing a king, 4 out of 52. And I would subtract the red kings, which are 2 cards. There are 2 red kings. They're right here. Okay, so I would subtract 2 divided by 52. Okay, if A and B, those 2 events are mutually exclusive, which mutually exclusive means that A and B have no outcomes in the intersection. Okay, so they have nothing in common. So that would be like a jack and a king. All I do is the probability of A plus the probability of B. So the probability of drawing a jack plus the probability of drawing a king gives me the probability of drawing a jack or a king. Okay, so in example 1, a card is randomly selected from a standard deck of 52 cards. What is the probability that it is an ace or it is a face card? So when we are doing these problems, we really want to look for keywords like or and. Because if I'm finding or, I'm solving for either this or this. But if it tells me to find an and, I'm going to be solving for this. Okay? So this is an or. I want the probability that I draw an ace or a face card. So they've given me a nice little diagram right here to help me. However, on your homework, or your worksheet rather, that the sub will give you, you aren't going to have nice little diagrams on all of your problems. So you can either draw one if you need to. You can Google a deck of cards and pull that up if you need it. Okay? So first, we want the probability of A, which is getting an ace. So there are 4 aces, and the probability would be 4 out of 52 cards. Then I want the probability of B, which is a face card. So if I go to my diagram, I have 4, 8, 12 face cards. So the probability of getting a face card is 12 out of 52. And I want to add those probabilities together. Now, I don't subtract anything because there are no aces that are also face cards. So once I get to this point, I'm going to add those together, and that will give me the probability of A or B. Okay, so remember, when you add fractions, as long as the denominator is the same, you just add across the top. 4 plus 12, 16. Denominator stays the same, so 16 divided by 52. So on the calculator, all I need to do is 16 divided by 52. And we're going to round to 3 decimals, so we get about 0.308. So there's about 31% chance when I pull a random card out of a deck, it will be either an ace or a face card. Okay, example 2. A card is randomly selected from a standard deck of cards. What is the probability that the card is a heart or a face card? Okay, again, I'm trying to figure out an or problem. So first I'm going to figure out what's the probability of getting a heart. So we're finding probability of A or B. So again, I have a nice little diagram. Here are all my hearts. Okay, there are 13 of them. So 13 over 52 is my probability of a heart. Plus, I need to figure out the probability of a face card. Here's all my face cards. Kings, queens, and jacks. There are 12 of them. So plus 12 out of 52. Now we need to think, are there any face cards that are also hearts? Well, since they give us the diagram, it's pretty easy to see that. However, on your worksheet, you might have to pull up a deck of cards and kind of check for that. So there are 3 cards that are both a face card and a heart. So I'm going to subtract 3 out of 52. Those 3 cards that are in the intersection. Okay, again, I can just do the numerators when I plug it in. So 13 plus 12 minus 3. So my numerator is 22, and I want to divide by the denominator, which stays the same, so 52. And I get about a 0.423 probability. So about a 42% chance. All right, let's go to the back. Okay, example 3. It says, in a survey of 200 pet owners, 103 owned dogs, 88 owned cats, 25 owned birds, and 18 owned reptiles. None of the respondents to the survey owned both a cat and a bird. What is the probability that they owned a cat or a bird? So what we're trying to find is how many, or the probability of owning a cat or a bird according to this data. Okay, so I want to find P, and instead of A and B, I'm going to use C and B for cat and bird. So I want the probability of a cat or a bird. So I'm going to go up to my data. I'm going to start with C, cats. How many people owned cats? Well, it tells me up here 88. So 88 people out of the 200 that were surveyed owns a cat. Then I want B, birds. Well, it tells me up here 25 people own birds. So I'm going to add the probability of owning a bird, which is 25 out of the 200 people surveyed. So I'm going to go to my calculator, and I'm going to add my 88 plus 25 and divide by the total, which is 200. So I get about 0.565. So that gave me 113 over 200, which is about 0.565. So about a 57% chance. Okay, the next bullet point says 52 people own both a cat and a dog. Okay, so this part is important. What is the probability that a respondent owned a cat or a dog. So I know how many people own both, but what is the probability of cat or dog? So again, I'm trying to find the or, so probability of cat or dog equals, first I need to figure out the probability of owning a cat. So remember those 88 people who own a cat out of the 200. That goes first. Plus probability of owning a dog. Up here it tells me 103 own dogs, so 103 out of the 200 surveyed. And now I have this information that 52 owned both. So since 52 have both a cat and a dog, I want to subtract that probability, so 52 out of 200, from the other two added together. Okay, so if we add up 88 plus 103 minus our 52, we get 139 out of the 200 people owned a cat or a dog. If I divide it out, it's about 0.695. So almost 70%. Okay, the last bullet point is the trickiest. It tells me 119 people owned a dog or a reptile. What is the probability that they owned a dog and a reptile? So we really need to pay attention to the ors and the ands because they are actually two very different probabilities. Okay, they're giving me the or. 119 owned a dog or a reptile. We're trying to find how many, or the probability rather, that they owned a dog and a reptile. Okay, so let's look back to our formula. I'm going to write it up here since it's on the front. Probability of A or B equals the probability of A plus probability of B minus the probability of A and B. Okay, so that was my formula from the front of the notes. I'm given the probability of A or B. That's this 119. So I'm going to fill in that part that I know right here on this side of the equation. So 119 out of the 200 people owned a dog or a reptile. Okay, so I filled that part in. I'm setting it equal to the probability of A, which would be the dogs. So I know that 103 people own dogs out of the 200. Plus probability of B, which is owning a reptile, which it tells me at the top 18 owned reptiles. So plus 18 out of 200. Minus, I want to know how many, or probability, that they owned a dog and a reptile. So I'm trying to find this and part. So I'm going to call that X. I'm solving for the and. So I'm going to combine my two fractions here. So 103 plus 18, which gives me 121 over 200 minus X. And I'm going to solve for X. So I'm going to move this fraction to this side. So I'm going to subtract it. Okay. Which will give me 119 minus 121, which is a negative 2 over 200 equals negative X. Okay, I'm going to go ahead and divide out my negative 2 divided by 200, which gives me negative 0.01 equals my negative X, and divide both sides by negative 1. So I get a positive 0.01 for my probability that they owned a dog and a reptile. Okay? Now we have one more thing to go over. It is called the complement of an event. Okay, so if